Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, especially if you're just getting started with Horner, today is a great topic. Here it is. Get started with Cscape 10 and Micro OCS. Today we're going to give you everything you need to know to get your new Micro OCS All-in-one Controller from Horner set up and configured with Cscape 10, our all-in-one programming software. All right, without any further delay, let's break down today's topic. Okay, we're going to start with a quick introduction to the Micro OCS All-in-one Controller from Horner, and then we're going to dive right into setting up the Cscape 10 all-in-one software, making a connection between your computer and the Micro OCS, and then we'll go through configuring the hardware, programming logic, configuring some screens, and of course there will be demonstrations throughout. Okay, here we go. Okay, let's take a look at the two primary product lines of all-in-one controllers from Horner. Now we have more than this, but we're going to focus for the next 2 weeks on the Micro OCS series, which we're covering today, and Canvas, which we're covering next week. Now both of these product lines are all-in-one controllers, or PLCs with a built-in HMI. The Micro OCS is ideal for simple applications, and Canvas also features advanced graphics, some built-in IoT protocols, and really just more memory and more speed. So those are the two product lines we'll be focusing on for the next 2 weeks. All right, let's dive into Micro OCS. Now the Micro OCS is available in color touchscreen models in the sizes of 4.3 inch, 7 inch, and 10.1 inch. And you can configure more than 200 user screens for each of these models. Now all of these models, as an all-in-one controller, feature a full built-in PLC. Now you can program this PLC from a logic standpoint using either advanced ladder logic, kind of a traditional American style ladder logic, or you can utilize the full IEC 61131 programming languages if that's your preferences. They're both available in the same all-in-one Cscape software, available for free from Horner. Now in addition to the 3 color touchscreen models, we also offer a monochrome model that is key-based. That's called the X2. Now, in addition to the built-in touchscreen with HMI capability and the built-in PLC with logic capability, you've also got built-in I/O. Now you can order the Micro OCS, in addition to the different screen sizes, you can order either a Model A option for I/O or a Model R option for I/O. And both of those options are almost identical. The only difference is in the outputs that are provided with each of the two models. Now all models A and R include 12 DC inputs, 4 of which are high speed for things like totalizing, high speed counting, or quadrature type inputs, for instance. The Model A features 12 solid state DC outputs, nice and beefy, half amp each, 2 of which are good for high speed signals, like PWM type signals, for instance. And then if you choose the Model R, you'll get 6 relay outputs as your primary outputs and 2 lower power high-speed solid-state outputs. Now the Model A and R both feature analog inputs and analog outputs. 4 on the input side and 2 on the output side. Now they're primarily 4 to 20 milliamp, although the touchscreen models also support RTD sensors on the analog inputs with a limited range of -50 to +200C. Okay, so without further ado, let's go ahead and demonstrate how to set up Cscape 10 so we're ready to make a connection and program screens and logic and do everything else we need to do in our control application. Okay, at this stage, I've already downloaded Cscape 10 from the Horner website by logging in to the Horner website. Now, if you haven't created an account on the Horner website, you'll have to do that first. It's not a big deal. We just need you to fill out a simple form that includes your email address and a password that you create. And you'll use those credentials for everything Horner. So I've already logged into the Horner website, downloaded the program, the install package, installed it on my computer, and it's now asking me to log in, and it should do the same for you as well. Now, again, your login to Cscape is strictly your email address that you've registered with Horner, as well as the password you've created on the Horner website. So let me go ahead and enter that now. Okay, now to keep things simple, I like to stay logged in so that every time I open Cscape, I'm automatically logged in. Okay, so let me go ahead and sign in here. All right, now, don't panic if your desktop doesn't look exactly like mine, because keep in mind, I installed Cscape a few months ago instead of just now like you may have done. So let me go over here to the default view. And again, what you see may not be exactly what you see here on the screen. But let's get some things set up so that we can start being productive. All right, we are going to start by pressing on this little Cscape icon here in the upper left-hand corner and going to Settings. Okay, now the first thing that we need to do in Cscape is to make sure that the logic styles that we prefer are available every time we create a new project or a new program. Okay, and that is done in this area here, all right, in the setup option. All right, so this is supported program types. Now at Horner, we like to give you choices. So we give you literally 3 different options in terms of logic styles when you're programming a Horner all-in-one controller. Now, you know, the way you program screens and the way you set up hardware and the way you configure networking, that doesn't vary from language to language, but you do have some language options. Now, one of them that is available, okay, is the old school traditional advanced ladder, where it's register based. In other words, every time you create a new variable, you need to map it to a specific register. Now, most companies have obsoleted this style. We've left it available to our customers because we've got a lot of old school customers that prefer to use it. Okay, but it's not ideal for you new users because, again, you do have to map every single variable to a specific memory location in the controller. I go ahead and leave that checked because there are occasions when I do need to use that programming style. Down here at the bottom, we have also another advanced ladder option, but this time with variable-based addressing. So what that means is when you create new variables, you don't have to map every single one to a specific memory location. You can go in and let Cscape, the software, do it for you most of the time, with the rare exception maybe when you've got a variable that's being communicated over a network, or maybe you have a variable that's directly tied to a specific I/O point, for instance. But most of the time, you don't have to mess with assigning register locations to variables, and you've got advanced features that are only available in variable-based languages, such as user-defined function blocks, which some companies like Rockwell call add-on instructions, as well as, you know, array support and those sort of advanced features. So in general, if you prefer just advanced ladder, I would recommend, especially if you're just starting out with Horner, that you check this bottom option for sure. And then finally here in the middle, we have the ability to support IEC editor programs. So would you prefer to have structured text as your language in addition to sequential function chart and function block diagram and a slightly different but still available ladder logic editor? Then that is the option here in the center. Now I'll make one more note here for enhanced IEC default. Now the Canvas controller, which we'll talk about next week, actually supports enhanced IEC, some advanced options when IEC is the language of choice for control on your project. So I prefer not to make that checked by default, but to just check it or select it on my Canvas projects. Okay, so you're going to want to make sure that the choices that you're interested in for your programming are selected. I'm going to leave all 3 of these selected here. Okay, so for now, we're just going to leave that here and say OK. All right, so next, we're going to want to open a new program or create a new program and set up the desktop the way we want so we can start being productive and editing new programs. All right, now, I'm going to go ahead and go back to the circle Cscape icon here, and I'm going to select New. So I'm creating a new control project. And the options that show up here are going to match what we just selected in the setup. All right, so in this case, let me go ahead and select Advanced Ladder with Variable-Based Addressing. Okay, I'm going to use that for this particular project. Now, once I do that, my desktop area fills in. Okay, now again, your desktop may not look like this, okay? And you may not want it to look like this, but let me show you how to kind of arrange things the way you want them. All right, in the Home tab up here in this left-hand side under View, you have the different elements of your desktop for editing Cscape programs. Project Navigator, which is selected, I have allocated right here. The Program Variable window, which is available for Variable Base Advanced Ladder as well as IEC, I have allocated down here. And the Project Toolbox, which is also selected, I have allocated over here. Now you may not want these in these locations. You may want them in different locations. How do you move them around? Well, you do so by clicking on the bar up here, dragging, and then moving your mouse pointer to the area that you want the docking to occur. And then you can stretch it to the size you prefer. Again, same thing here. Where do you want it? Do you want it just floating? Do you want it docked somewhere? Where would you like it? Okay. And then again, once you have it docked, if you want to have it docked, you can then size it the way you want. Now the beauty of this is you can, again, size these and arrange these the way you want, and every time you open up Cscape, it should come up pretty much set up the way you want, okay, or the way you last left it for sure. Okay, now let me make one other note here, and that is you may not want to dock, for instance, you may not want to dock the Program Variable window where we work with all the different variables in our project. We may not want that docked here at the bottom. We might want it docked on a different monitor, so you can even do that if that's the way you'd prefer it. Leave it maybe as a floating window and just move it off to a different monitor. I've just got a single, 1920 by 1080 monitor that I'm working with here. Okay. All right. So again, the next time we log in, or every time we log in, we should see the desktop arranged pretty much the way we want it. Okay, now that Cscape is set up and ready to go, we're ready to establish a connection between our computer and our Micro OCS. And we've got two different options, as I mentioned earlier. The first option that's available on the Micro OCS is USB. So you can connect a standard USB cable, which has USB-A or maybe USB-C, whatever matches your computer on the computer side, and Mini-B on the OCS side. Okay, now, if you'd like to purchase a cable from Horner, you can do that, okay, but it is just a standard cable, all right, and that cable is the HE-PRG Mini. All right, again, available from Horner, either on our website or from one of our distributors. And that cable is USB-A on one end and USB Mini-B on the other. Okay, now the other option for configuration is just to use Ethernet. And for that, of course, you just use a standard Ethernet patch cable. And of course, that's only on the touchscreen models. The entry-level X2 monochrome key-based model only supports USB. So again, if you're using Ethernet, we'll show you how to do that here in a minute as well. For that, you'll just need a standard Ethernet patch cable. Okay, the first method we're going to use to communicate between Cscape 10 on our computer and the Micro OCS is using USB. And the Micro OCS utilizes Mini-B, okay? So not to be confused with USB-C or the Micro B, which is a lot skinnier. This is Mini-B. And again, you can get this cable from anywhere, including the Horner website. All right, so we'll just plug it in to the USB programming port here on the back of our Micro OCS. Okay, now that we're physically connected, let's make the virtual connection between Cscape on our computer and the Micro OCS. All right, let's look in the lower right-hand corner, and we can see here that we have no communication right now. Okay, so locally we have no communication. Our target, or the controller that we want to talk to, is controller number 253. That happens to be the default address of an OCS. It's officially a CAN address or a node address, but 253 is the default, but we have no communication going on here. Okay, so to establish communication over USB, let's go up here and make sure we're in the Home menu, and let's click on Connection Wizard. Okay, these are all the different ways that we can connect to a Horner OCS, and we want to use USB here. All right, so I'll click on USB and hit Next. And then what I should see here is controller USB port with a specific COM port that's been mapped to. Now, if I've got multiple COM ports on my computer that may be connected to things, I may need to pull it from a pull-down list, but I should see controller USB COM port if I've got a Micro OCS connected. Okay, I can hit finish, and then what I should see happen in the lower right-hand corner is I should see, instead of local no comms, I should see local 253, target 253, and I might see an R here for run mode, because from the factory, it might have a demo program in run mode. I've deleted that demo program in my case. And so now we've established a connection. Now let's say instead of a Windows PC running Windows 11 or Windows 10, let's say instead you've got a Mac laptop that's running, say, Parallels or VMware, and you're still running Windows, but it's through some sort of virtual operating system or virtual machine type software. In that scenario, the only difference is we would go to the connection wizard, and instead of selecting USB, we would select serial, okay? And we'll end up with the same result. So when we connect serial and hit next, it's going to basically ask us for a port number. Now, if we don't know what that port number is, we can hit the I don't know button, and it'll come back and tell us, okay, we've got a device detected on port 3. We can hit finish, and in the end, we'll end up with the same result. A nice connection over USB, even though in the case of a Mac laptop, we selected serial port. Okay, so that is a connection over USB. Now let's demonstrate connecting over Ethernet. So I've already connected my Ethernet cable to the back of this unit. Now, don't let this message throw you off here. I've erased the demo program that came with my controller from the factory. In your case, if you're just powering up the OCS for the first time, you probably still have a demo program loaded in there and you don't have this display error. This is the message that's displayed anytime you don't have a program loaded, or maybe anytime there's no screen loaded for screen number 1. So don't let that throw you off. Okay, so we've connected physically the Ethernet cable to the back of the unit. Now we're going to pull up the built-in system menu. All right, and to do that with a unit that doesn't have a dedicated system key, we press in the upper right-hand corner. The system button will appear. We'll select that. Okay. And what I want to do is I want to select that first option of set networks. Okay. All right. What I want to do to connect over Ethernet is I want to configure the OCS with an IP address that's compatible with my local network. Now in my case, you can see, well, in any case, you can see the default IP address here. But in my case, to make it compatible, I need to change the IP address. Let me hit enter first. Okay, so I hit enter to make it editable. And I need to change the IP address, the 3rd and 4th octet. So I'm going to make this 0, and then let's say 253. Okay, that's an available address on my network. I'll hit enter. All right, and then my net mask is set to a viable entry there, 255, 255, 255, 0, and to establish a connection, the gateway is not important. Okay, so now we should be able to connect to the Micro OCS over Ethernet. All right, so we're going to go back to the connection wizard. Okay, let me go ahead and move my mouse over here to the connection wizard. And this time I'm going to select LAN and next. And then I need to select or configure the IP address of the OCS controller. All right, I'm going to set that at 253 to match what was just on the system menu and hit finish. Okay, and then I should have a connection here in my lower right-hand corner, which I do. All right, very good. So now we've connected over Ethernet. Now that we've established communications, let's move on to the rest of the setup and programming process. All right, next is hardware configuration. We want to make sure that Cscape software knows the specific controller we're communicating with. Now, because we weren't connected with our controller and talking to our controller when we powered up Cscape, it's using the default OCS controller here. Now, if we had been physically connected to our OCS that we're using today, the Micro OCS 7 in my case, when we powered up Cscape, then that would be showing up here, but it's not. The default controller is instead. So what I'm going to do is I'm going to hit Auto Config down here in the lower right-hand corner, okay? And then once I do that, it automatically fills in the specific model that I am talking to right now. Great, that's what we want. Now, because I'm communicating over Ethernet, the first thing I like to do from a configuration standpoint is make sure that I've configured the LAN port of my controller with the IP address that I want it to have. Instead of the default IP address, I want it to have an IP address of, in my case, 192.168.0.253. And if I have a gateway that I'm going to use in my application for getting out onto the internet, for instance, I could program it here as well. Okay, so I've programmed my IP address into my LAN 1 configuration so that when I download the program, or every time I download the program, I don't accidentally change the IP address to something that will cause communications to cease once it's configured. Okay, so that was the first step. I always like to make sure if I'm programming over Ethernet that I do that. Next, I'm going to go and configure the I/O in the Micro OCS by clicking on the Local I/O tab. Okay, I'll click Config and then Module Setup, and now I can go in and configure all the built-in I/O in my controller. So on the input side of things, let's say I'm using positive logic on the input, so 24-volt signals on the input pin is going to cause a logical 1. That's fine. And if I want to use high-speed counting, I would configure that here. That's for another day though, so let's not use high-speed counting in this example. For digital outputs, if I have high-speed outputs or PWM outputs that I want to configure, I would configure those here. Otherwise, I can just leave in my case, I've got a Model R here that I'm dealing with. So in addition to the 6 relay outputs, I also have 2 solid-state outputs. I can either leave those as sourcing out or syncing out. I'm just going to leave everything at the default for now. Okay. On the analog input side, I need to enable any of the 4 analog inputs that I want to use. So let's say I want to use all 4 of them in 4 to 20 milliamp mode. So I could configure that here. If I wanted to use one of them as an RTD PT100, I could do that here instead, but let's stick with 4 to 20 milliamps. And down here under filter constant, this is how much filtering of the analog signals that I want to do between 0 and 7. So 7 being the most amount of filtering for the steadiest signal with a little bit of lag, 0 being absolutely no lag, but with a little more jump in the signals. I'm going to go ahead and set this to a default, let's say, of 3 for myself, and hit OK. And on the analog output side, I need to decide if I want to enable these or not in 4 to 20 milliamp mode or not. And I'm going to go ahead and enable those. Okay, all right, so that's the basic configuration of the I/O that I've now done. As you can see, I'm hitting OK everywhere as I go. All right, so that's the hardware configuration. Okay, now that we're configured, next let's program us some simple ladder logic. All right, so I'm going to start with just a simple start-stop circuit. All right, so I'm going to click on the normally open contact here and just place it in row A of somewhere on my logic desktop here. All right, and I'm in the main routine, which you can see over here under main loop module. All right, so let's just do a simple motor start stop. So I'm going to, on the fly, I'm going to create a variable called start push button. All right, start push button does not exist. You want to create this variable. I do in this case. All right, And in this case, it's actually a variable that I want to tie to a specific input terminal on the OCS controller because it's physically wired as an input push button, let's say. Okay, so I can leave everything as default. Boolean is fine. However, under mapping, this is where I want to specify which input terminal, in this case, I want it to be mapped to. So I'm going to say %I1. Okay, so that means on the first digital input, I'm going to be mapping the start push button variable. Okay, the % indicates a address. You don't have to type in the % sign. The I indicates a digital input, and 1 indicates it's the first digital input. Now, if this was physically wired to the third digital input, I would put here %I3 instead. I'll hit yes. All right, and now as you can see, it's automatically created a new rung with start push button in the first column. Okay, and I can continue on from here. All right, now let's say next I have a stop push button. So I'm going to grab a normally closed contact, place it in line here. Again, I'm creating variables on the fly. I don't have to do that, but I'm doing that in this case. Okay, it doesn't exist. Do I want to create it? Yes. Where is it mapped? Well, let's say it's the 5th digital input is mapped to the stop push button. So I would type in %I5. Okay, and there we go. Now let's say I have my motor output. We'll just call this, let's just call it motor. Does not exist. Do I want to create? Yes. And again, the only reason I'm mapping all of these variables is because they are actually connected to real world terminals. So in this case, a digital output is a %Q in the Horner mapping scheme. And if it's the first output, then I'm going to leave that as Q1. Okay, and then finally what I need to do is I need to put a parallel contact around the start push button. Now, if I don't like it being here in the first column and I want to move it over here to give me some room, I can do that. I can click and drag over to here, but I've lost my connection with the left rail. So I can then right click and say new rung. So if I move things around and lose this connection here, I can always right click and establish a new rung. All right, now I'm going to click on the branch tool, and then around the start push button, I'm going to make a path and then drop another normally open contact. All right, and I'll call this one motor because, again, I'm just sealing around the start push button. All right, now, when I started typing in motor, it just showed up here. All right, now let me run through one other thing. If you don't move this contact over, and you don't have to move it over, and you want to just put everything here in the left, in the first column, column A, make sure that you draw in your branches first before you drop your parallel contact. That's because if you just drop the parallel contact first without the branches in column A, it's going to start a new rung number 2, which is not what we wanted to do here. Okay, so now I've got a simple start-stop circuit, which I've created. Now let's just do a simple timer, okay, so that you can see how timers work real fast. Let's do that. Let's say we just want to time how long the motor is running. So I'm going to get a normally open contact here, drop it. This time I'm going to drop it in the second column. I could drop it in the first one. Okay, and this time it's going to be, again, the motor contact, because whenever the motor's running, we want to time that. Now I dropped it in the second column, which means I have to manually create the new rung. If I'd have dropped it in the first column, it would have happened automatically. Now I'm going to grab timer from this area here and place it in my logic. Now, I need to assign a variable name for the timer. So let's just call it motor timer. All right, what's our ticks or resolution? Let's say 100 millisecond, that's fine. What's our preset value going to be? Let's say that we want to pass power flow after 30 seconds. Well, that would be a value of 300 in 1/10 of a second ticks. All right, we hit OK. And because we're defining everything on the fly, that's why I'm getting these messages pop up here, because these variables don't exist. So I do want to create them in my case. And I can leave everything at the default here. This is not mapped to any specific real world input. It's just an internal timer. so I can leave everything at the default without filling in mapping here. All right, and away we go. Now, once this times out, I'm going to want to have a coil turn on here, let's say, and I can drop that here. And in this case, let's say we just want to give this coil a name. And again, it's not tied to any real world I/O point. So I'm just going to call it, what did we decide here? This was 30 seconds was our fixed timeout. Now that could have been a variable timeout, but we made it fixed. So let's just call this motor run 30 seconds. How about that? Again, we're creating all these variables on the fly. It's internal, so we don't have to map it. And there we go. Okay, so we just have some really simple start-stop logic here, along with another little bit of logic that turns a coil on after the motor's been running for 30 seconds. Okay, really simple stuff. Now let's create a screen, okay, to display some of this information or even allow us to maybe start or stop the motor. All right, so I'm going to go over here back to the Project Navigator, and under User Interface, I'm going to expand that. And then under Main Screen, I'm going to right-click and select New Screen. All right, I'm going to call this, I'm going to give it a name. I could just leave it as Screen 1, but I'm going to give it a name. Let's just call it Motor Start. All right, and now as you can see here, I've got a Motor Start tab that appeared along with some screen editing area here. Now I want it to fit totally within the window, and in my case that means I need to zoom out a little bit. Let me do that a couple times. Okay, there we go. And what I have is I have a screen editing area with a default background of gray, and it's showing a grid, kind of an alignment grid. All right, let's go ahead and take a look at how we might want to adjust the grid, for instance. If I right click on the background and I can select grid setting, this is showing me how my primary grid, the big squares, and my secondary grid, the dots, are actually set up. How many pixels in the X and Y direction for each. So in my case, I'm not going to want to see or snap to the primary grid. I'll just see and snap to the secondary grid so you can see how the look has changed here a little bit. All right, of course, none of this shows up on the screen, only the gray background. All right, so now let's go ahead and just add a pilot light that shows us if the motor's running. All right, so over here, the project toolbox now is showing graphical objects instead of logic objects. All right, so I'm going to select live graphic data, and I'm going to select a lamp or indicator. Okay, and I want to tie this to whether the motor's running or not. So I'm clicking and dragging to size this up here. Now by default, it has this funky light bulb. I'm not sure why we did it that way, but we did. So let's change the default from, I double clicked on that, by the way. Let's change the default from bulb to just, let's say round. Okay, so I'm gonna get a round pilot light here. And let's give it a 3D bezel. Okay, and now we need to tie it to a variable. And the variable we want to tie it to is motor. So we can either just type in motor, or we can select this arrow key and pick it from the list of variables. So go down here and find, yep, there it is, there's motor. Okay, all right, so I'll double click on that. All right, so now I've tied this to motor. Now, instead of saying lamp here, let's go ahead and configure the legend plate for something a little bit more, logical here. So let's select it as motor, or just motor. Yeah, let's just make it motor. All right. And from a color standpoint, when the motor's running, let's make it bright green. When it's not running, let's make it, let's say dark green. All right. And say okay. All right. So now we have a legend plate at the top, okay, that says motor. Now, if we want that to be larger, I'll double click on it again. And under legend plate properties, we can go back to legend, and let's make the font a little bit bigger. Okay, so we can do that if we choose. All right, and there we go. So now we have a pilot light that's on whenever the motor is on. And then let's say we want to have a data field that tells us how long the motor's been on, that's tied to the timer preset, or the timer accumulator for that motor run timer. All right, so this time Let's minimize live graphics data and let's go to live text data, and let's select timer data. Okay, so well, actually, let's do it this way. You could select timer data and then it knows you're talking to timer type information, but you could also just select a numeric data field, which is probably a little more common in general. So I'm going to select numeric data field, click and drag for the size, and then double click on it. All right, I need to tie it to a variable. First thing I have to select is this a 16-bit variable or a 32-bit variable that I'm tying it to? It's 16-bit because I've just got a standard timer accumulator that I'm tying to. All right, so I'll leave that at 16-bit, and then I'm going to browse my variables here until I find my motor timer, and specifically I want to expand this and select accumulator. So this is the motor timer accumulator. All right, now the format for this data is in decimal, not signed decimal, but just decimal. All right, and then how many digits do I want to display? Well, this is going to time up from 0 to 300 in tenths of a second. So there's no point in displaying any more than 3 digits. Also, I can display, for instance, a tenth of a second type field here. All right, so when it's at a value of 300, which is the max, it'll show 30.0. And that decimal point will be displayed even though the data doesn't have a decimal point in it. Okay, at least not the variable value. Okay, so I'm going to select 12.1. Under engineering units, I'm going to put an S here for seconds. I don't have to do that. That's optional. All right, and then this is not a write-enabled data field. Okay, this is just coming from a timer value. Under legend, I'm going to put elapsed run time. All right. And let's make the data font a little bit bigger. And let's see what it looks like. We can always change it from here. Okay, so elapsed runtime in seconds. Let's make this pop a little bit. Let's give this a background of white. All right. And there we go. Okay, so we've got a motor run indicator and elapsed runtime. Now let's say, for the last thing on the logic side of things, let's say we wanted to have our own start button here, okay, to start the motor from the touchscreen. Let's go back to logic, and I can just click here on the main tab to go back to logic, and let's add another option to the start-stop circuit. Let's add another parallel option to start the motor. So I'm going to add the branches here, and then I'm going to drop another contact, and I'm going to call that Start TB for touch button. I could call it whatever I want. It really doesn't matter. But I'm going to call it Start TB for touch button. Okay. It does not exist, so I want to create the variable I do. But since it's not tied to any real-world I/O point, I don't need to do any mapping. So I can say yes. And now I've created another contact that when it turns on, will start the motor. Let's go back to our screen. Okay, and this time under under touch objects, let's select a button or switch. I'll click and drag. Okay, I'll select a round button in my case. All right, what variable do I want to tie it to? Well, I want to tie it to my start touch button that I just created. All right, I'll go to indicator properties. Do I want to have text on here that says start, stop, on, off, something like that? Let's say no in this case. And then what colors do I want to use? Let's just say that when I push the button, I want it to, once again, let's say with similar colors. When I'm on, I want it to be bright green. When I'm off, I want it to be dark green. Okay. And okay. And then under legend plate, let's assign a legend plate and let's call it start. We'll just call it start. How about that? And bump it up size-wise and say okay. And okay. And let's see what it looks like. All right, so now we have a start push button. We've got a motor indicator light. We can make this a little bigger if we want. Okay. and we've got an elapsed runtime indicator. Okay, so this is pretty much what we want. Next, we need to download this program into our controller. So again, verifying we have communications. All right, let's go ahead and hit the download button. We can use Smart Load. All right, so it'll only download what's changed. Now we're going to get a warning, and that's because we're configuring over Ethernet. So it's reminding us that if we don't have the IP address set properly in this program, in the hardware config, then midway through our download, we're going to lose communications because we would have accidentally changed the IP address of our controller. So we already made sure earlier that our IP address for our program is what we want. So I'm going to say continue or yes, and it's starting the download process. Okay, so we'll let the download process complete. Now, one common mistake that I know I still make sometimes is after a download's complete is not verifying here in the local, the lower right-hand corner, is not verifying that my controller is in run mode. Okay, so once my download finishes, I'm not going to have anything happening in my program unless I actually put the controller into run mode. Now, if your controller was in run mode before you did your download, it'll go out of run mode, do the download, and then go back into run mode so you don't have to worry about it. But in my case, it was stopped or in idle mode before the download, so I need to manually start it. So I'm going to hit the run key here. And now down here you can see, okay, everything is now running. Turning to the bench, let's go ahead and make sure everything is working like we want. Now, I probably should have programmed in a stop button on my touchscreen as well to make this demo a little easier to demonstrate since I haven't physically wired up any of my start buttons. But let's go ahead and hit the start button on the screen. And as you can see, my motor is now running and my elapsed runtime timer is timing up. So everything appears to be working the way we want. If we go back into Cscape, okay, let's go to the main tab where our logic is, and let's press the debug button. Okay, so we're going to go into debug mode so we can see live what's happening on the screen. Okay, logic-wise. So up here at the top, there is a debug icon that we can press. We can also go to the debug tab and find that same debug mode button if we want. Okay, so now we're going to look at debug mode here. And this is showing us live what's happening on the logic, from a logic standpoint. And everywhere where we're passing power flow, we've got a red indication. And as you can see, we're not pressing our start push button right now, but we're sealed in around the motor. Okay, so I hope that helps give you just a quick startup on how to quickly set up Cscape, get connected, do a little bit of logic, write a little bit of screen type information, and then test it. Okay, so that does it for our material for today. This is a reminder, we're here just about every Tuesday at 2 o'clock, either fully live or pre-recorded, but we always have someone standing by to answer your questions. If you're watching live, give us those questions in the chat section. If you're watching a replay of one of our videos from our YouTube channel, just give us those questions and comments in the comment section. Okay, our Horner 2025 OCS training schedule is fully filled out. In terms of what classes are going to be available in 2025. You can see them there on the screen. If you'd like to go and participate in one of our basic or advanced training courses, just go to our website and get signed up today. The feedback we get is that it's a really good experience. Typically, you're looking at 2 or 3 day courses. I think most of them are set up for 3 days these days, or 2.5. And again, most of the people we talk to who participate in these classes really think it's worthwhile. So sign up for yours today. Okay, for more product information and other ways to interact with Horner, go to our website at hornerautomation.com. Or if you'd like to check out more YouTube videos like this one, go to our YouTube channel. And of course, we're also very active on LinkedIn. All right, we've got many more topics coming for December, including next week when we talk about setting up Cscape 10 with our Canvas all-in-one controller, so you don't want to miss that. Also, if you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything, and if you choose notifications, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, when we show you how to set up Cscape 10 with the Canvas all-in-one controller, let's all get out there and do some good.